This is a video for the final review in my Calculus 2 class. Let's take a look at example 1. Suppose we have the integral from 1 to 2 of x to the fifth natural log of x dx. So this is a classic integration by parts problem. I'm going to let u equal natural log of x, and I'm going to let dv be x to the fifth dx. du is 1 over x dx, and v is 1/6 x to the 6. So the integral from 1 to 2 of x to the fifth natural log of x dx is equal to 1/6 x to the 6 natural log of x evaluated from 1 to 2. So you remember it's a definite integral. Then we're going to go minus the integral from 1 to 2 of 1/6 x to the fifth dx. Now, if we look at the first part, I'm going to replace x with 2 and x with 1 and subtract the results. So when I do that, I get 64 over 6 times the natural log of 2 minus 1 over 6 times the natural log of 1. Now, then I'm going to go minus, and then the integral of 1/6 x to the fifth dx is 1 over 36 x to the 6. But we evaluate from 1 to 2. Now, finishing this problem, we get 32/3 natural log of 2 minus, and then it's 64 over 36 minus 1 over 36. In other words, for this part of the integral, or part of the result, I replace x with 2 and then x with 1 and subtracted the results. And that's what I did over here. So again, I get 32/3 natural log of 2 minus the quantity 64 over 36 minus 1 over 36. But that's 32/3 natural log of 2 minus 63 over 36. And then we can write this as 32/3 natural log of 2 minus 7 over 4. And that's example 1. Let's take a look at example 2. This is example 3. Suppose we have the integral of square root of x over 1 plus x cubed dx. And this one's real slick because we can write this as the integral of x to the 1/2 divided by 1 plus x to the 3/2 quantity squared. And so this can be done by use substitution. I'm going to let u equal x to the 3/2. du is 3/2 x to the 1/2 dx. It's just power rule, right? 3/2 minus 1 is 1/2. So if I solve for x to the 1/2 dx, I get 2/3 du. And then coming over here, the integral of x to the 1/2 over 1 plus x to the 3/2 squared dx is 2/3 the integral of 1 over 1 plus u squared du. But that's 2/3 arctangent of u plus c. But u is x to the 3/2. And so the correct answer here is 2/3 arctangent of x to the 3/2 plus c. If we take a look at example 4, suppose we have the integral of 1 over x times the square root of 4x squared plus 1 dx. But I can write this as the integral of 1 over x times the square root of 2x raised to the second plus 1 dx. So I'm going to do this by trigonometric substitution. So I'm going to put a theta here. The side opposite angle theta is going to be labeled 2x. The side adjacent to angle theta, adjacent is just next to, is labeled 1. And so the hypotenuse is the square root of 4x squared plus 1. So 2x is equal to tangent theta, which says x equals 1/2 tangent theta, right? Dx is 1/2 secant squared theta d theta. And square root of 4x squared plus 1 is equal to secant theta. Now, if we go to label this and convert it to theta, we get the following. The integral of 1 over x square root of 4x squared plus 1 dx is the integral of 1 over, and then I'm going to get 1/2 tangent theta times, and then this is secant theta, and then I'm going to replace dx with 1/2 secant squared theta d theta. Now, I can get rid of the 1/2s right here, right? And this can be written as the integral of secant theta divided by tangent theta d theta, like so. Now, this can be written as the integral of 1 over cosine theta divided by sine theta over cosine theta d theta. The cosine thetas cancel, and this is the integral of 1 over sine theta d theta. But 1 over sine theta is cosecant theta. So this is the integral of cosecant theta d theta. But a couple ways we can think about this is natural log of the absolute value of cosecant theta minus cotangent theta plus c. Now, another way to express this is you can write this as negative natural log of cosecant theta plus cotangent theta plus c. But we're not done, right? So if we go back to the triangle's here. So we have 2x and 1 and the square root of 1 plus 4x squared. And so this is negative natural log of. Now, cosecant theta is, okay, so remember, sine theta is opposite over hypotenuse. So cosecant theta is hypotenuse over opposite. So we get square root of 1 plus 4x squared. And we're going to divide by 2x. And then I'm going to use this equivalence here. Then I'm going to go plus, and then I'm going to get 1 over 2x plus c. And then I would just make it one fraction. So this is negative natural log of 1 plus the square root of 1 plus 4x squared divided by 2x. Remember, that's an absolute value, plus c. And that's how we do example 4. Let's take a look at example 5. That'll be the last one for this video. If we have the integral of tangent to the 5th theta, secant cubed theta, d theta. Now, this is what I would do. I'm going to save off a secant theta, tangent theta. Okay? Now, if I save off a secant theta, tangent theta, in parentheses, I have secant squared theta tangent to the 4th theta. D theta. So this is the integral of secant theta tangent theta times secant squared theta times tangent squared theta squared, d theta. So this is the integral of secant theta tangent theta times secant squared theta times, now in parentheses, I'm going to have the trig identity secant squared theta minus 1. That's just another name for tangent squared theta. So we'll go for the different color route. Now, I'm going to let u equal secant theta, because I just happen to know that the derivative of secant theta is secant theta tangent theta. And that's present right here. So du is secant theta tangent theta d theta. So this is the integral of u squared times, and then it's u squared minus 1 raised to the 2nd du. So this is u squared times u to the 4th minus 2u squared plus 1 du. Distributing the u squared inside, we get the integral of u to the 6th minus 2u to the 4th plus u squared du. So we get 1/7 u to the 7th minus 2/5 u to the 5th plus 1/3 u to the 3rd plus some constant c. But what was u? U is secant theta. So we get 1/7 secant to the 7th theta minus 2/5 secant to the 5th theta plus 1/3 secant cubed theta plus c. And that's a good stopping point for this video. This is a video for the final review in my Calculus 2. And we looked at examples 1, 3, 4, and 5. Okay, thank you.